Well, I've had the lab started up in early 70s. Then I was found out the effects started happening in 1979. And Alexis Pizarro, who I give credit to, found my research and then promoted it to the U.S. government. And other scientists. And that was quite a pace of activity for the last 10, 11 years of scientists coming and going. And about 750 demonstrations, but not all to scientists. Some media people would come in. And
hey, we came in, we're going to show some samples on your floor in your apartment and let you explain the other effects that happened with those.
Okay.
So we'll go to that. There's your floor covered with all these samples there.
This is, yes, I pulled out a lot of samples. Here's a aluminum piece that has, didn't want to separate, but blew up from inside. And I'm reaching over here for a huge piece of aluminum round bar stock, 2 inches. And it appears that it exploded outward like, well, if you've seen the movie Alien, like an alien popped out of there or something. That's a crude way of putting it, but...
many different effects, from the jelly molding, shaking, to pulling apart, to almost disintegrating, huh?
To disintegrate.
And then some of, like you observed before, and it was tested. Now, what happened here?
So I'm demonstrating what they call a large-scale monopole, as called by the scientific community. And one end of this is highly magnetic, and the other end is just zero. There's nothing on it.
So that was one of the effects after being in your target zone.
Yes, written up in Extraordinary Physics by Thomas E. Bearden. Large-scale monopolar activity.
And you can explain all the different metals and plastics and everything that, you know, you experimented on.
All right. That sounds good. Well, here we have the first test was an ordinary empty milk crate. It takes off in a bit of an arc. This is about 1988 time period, when I had about 5 effects per hour.
Just flies off, right.
Here we have
whoa.
2 things going off at one time. We have now a wooden bowl and a small tool or some kind on the other side there that...
So if we watch on the left, that tool's going to fly away, isn't it?
Yeah.
Oh, there's a bowl first.
There's a bowl. Oh, well, okay, there's a sheet of plastic, a blue plastic object there, about 1/8 of an inch thick, and it eventually takes off. And we have some foam and plastic material, an empty 5-ml bottle. He takes off, and there he goes. Lift off, as Jack Houck would say. And we got a wrench.
Oh, that's a wrench. And those are
that's a wrench.
Pretty heavy.
Yep.
Yeah, there it goes. It flies away like it's just a feather.
Here we have some stainless steel bars that sort of rubbery and almost lifting off. This one is just wiggling around a little bit like a snake looking at you. No, he wants to take off.
What do you think is going on? Is it being attracted or pulled by something?
It's interdimensional. And here we have water.
Now, we would assume this is boiling, but there's no heat, is there?
No, and it's also in a wooden bowl and also on a wooden plank, as I recall, this experiment.
So this would be just the effect of the water itself, the molecules interacting. Huh?
Yeah.
But we'll repeat again, there's been no heat, nothing gets hot, it does not boil, or...
You see no steam coming off of it.
Right. Because even the metal never exhibits any heat, does it?
No, it's cold. And here we have what they call the breathing effect, which is very rare, but was captured on this particular incident on an empty bleach bottle. And you see there's a compression. Either there's... the molecules of air are being compressed and expanded as much like the metals.
It makes it look animated, like it's coming alive.
Yeah, yeah. A lot of the scientists even speculate that this energy has an intelligence to it.
That's it.
Yeah.
Yeah.
On the high levels in the U.S. government, guys. Here we have another piece of stainless. He starts to wiggle around a little bit like a snake, meaning that it's turn quite rubbery. And is affected by the fields, or the fields affect it, set up resonances.
Is that probably the molecules themselves making it changing?
It's on the subatomic level, basically, these effects. Here we have a piece of aluminium that wants to separate itself from its whole self. And other samples along there are large pieces of aluminum. And
so that breaks apart.
Yeah, that slowly is magically...
You used to have to sit and fine-tune the equipment.
Some nickel steel, I believe. Yes.
And then these large, heavy, solid objects then, would just start shattering and pulling apart.
In the early days, it was kind of like one effect a day or something, but now, or in 88 and 89, it was 5 per hour.
So there was more control ability at that point in time after several years of testing.
Mm-hmm. Lots more control.
I see, once again, is the water being attracted out?
It's being
forced up.
Yeah, it can almost lift it. So it actually has lifted out, but on this particular case, it's just grabbing at it and then trying to get it out. And what's coming out of there is like little round balls of it. Here's a huge piece of tin foil, and when it takes off, I believe there's a set of lamps sitting on the table, and the light bulb will go out too. This crawls out of there and takes off.
So there's a light bulb in that carton on the left.
There's an empty bucket I decided to put on the test table.
You might get drenched if you put water in, and there goes the light bulb right out of the carton.
Yeah. Now we get into yogurt. We're getting desperate for samples, so we go right
You'll try anything.
The lab refrigerator and then put this stuff out. I believe it was a Frosty. And as you can see, it's almost like there's a gravity coming up, field coming up this way, and is pulling this piece up. And it's interesting because eventually it takes the whole cup along with it.
Is the idea that this target area has its own field then going on within it?
And sometimes samples will join together. In this particular case, okay, now we have a carrot. Well, I had to do this. I had to put a carrot in there.
Try vegetables here.
And it just nicely cut itself in two. Probably due to the water, water distortion. It's like...
This is one amazing shot. Now, how much does that weigh?
That's about 60 pounds.
That's a cannonball, right?
That's a old cannonball. And alongside that is a nail puller.
Now, this cannonball, what's going to happen here? It's gently, I mean, it's just like it's floating.
It's like it's floating, but also there's, with this particular sample, there's movements that are not, they almost look man-made, which is kind of interesting. As if the field was actually, the field would go out and there was some kind of intelligence behind it, or a little man behind there with a stick welded on to the cannonball. But
see, it turns. It'll turn this way on its axis, and it'll turn the opposite way. So it's not really consistent. It's fairly erratic in its movements, isn't it?
Very much so. It doesn't seem to conform to the other test samples. But it was fascinating, and as you see, there's no camera jiggling. I had to put it down.
So the camera is sitting still.
Oh, it's sitting still in this one, except for a few shots. But you're getting into weight like that, it gets dangerous. So we had, I think it was a 1,000-pound transformer, go off about an inch off the ground and went back down and shook the foundations. But
oh, there that goes.
He took off.
He took a while, but then when he went fast.
Yeah, right up.
Gee.
No, the cannonball is still wobbling around there.
And then it turns a little faster.
But you see, the funny part about this is that it even stops and reverses its movements. Whereas if it was out in zero gravity, it would just be going like this, very slowly.
Yeah,
but here
it goes from one side to the other.
Yeah.
It reverses itself.
It's like it's a lot of interference. Well, probably a lot of interference.